Good morning, my name is Nuria Sanchez and I'm working at CIEMAT, a Center for Energy, Environment and Technology Research. The new platform to quantify the energy saving potential in existing residential buildings in a northern Spanish region is designed to be a springboard for a discussion on the topic of energy efficiency in buildings, in which I have developed part of my professional career. I'll start by describing the main objectives of this study developed in the frame of the Spanish research project L'Habilitaje Sol. This research creates a new platform to quantify the energy saving potentials of different retrofit measures and the solar and geothermal fraction covered by these two renewable technologies in an area located on the north coast of Spain. And why is it important? Well, it's important because this tool can help local authorities and other stakeholders to identify priority areas that maximize the reduction of the energy consumption and minimize the greenhouse emissions. Now we'll move on to the description of the Geographical Information System platform in detail. This information system allows quantifying the natural resources as well as the building stock available to minimize the energy consumption of residential buildings in Asturias, which is a region characterized by temperate climate. The final energy potentials calculated by this tool depends on the meteorological conditions, geomorphological characteristics, constructive requirements, and normative restrictions. All these variables are considered as input information into the platform, setting constraints and limitations of the final results. The representative building stock is according to the Spanish cadastre. Before moving on the next slide, I just like to say that the energy potentials reached by these building models have been calculated through the use of dynamic simulation tools. I would like to shift focus now to the most relevant variables that influence on the energy performance of residential buildings. A key input matrix is composed by information related to the climatic, volumetric, constructive, and operational characteristics of the representative building typologies in this region. Regarding the local climate conditions, 3 normalized climatic zones are selected based on a specific climate classification developed by the Spanish Technical Building Code. Based on the cadastral statistics, 4 representative building typologies are identified. Building characteristics and operational conditions are needed to fill the inlet information of the simulation models. 4 Spanish regulations have been used, and the most representative values defined by these regulations are used for building envelopes, windows characterization, and internal gains. And these values meet the minimum construction and operational conditions requirements. Let's now look at the dynamic simulation environment. The first step is the creation of representative building models. Next, different input variables of these models have been modified to carry out a multiparametric study. And finally, the output variables of the simulation batteries are used to develop the analysis metrics of the platform. And post-processing evaluation has been done to create the databases of the platform. Heating, cooling, and annual loads have been assessed to calculate the theoretical retrofitting potentials of its configuration. As I have previously mentioned, the Principado de Asturias is a region characterized by high heating needs and low cooling needs. The first output of the platform is the maximum retrofitting potential reached by each municipality. The image is a real screenshot of the platform, showing very different values of potentials based on the climate, the type of building, and the year of construction. These potentials are calculated with respect to the minimum value of the thermal loads, which corresponds to the Spanish regulation defined after 2013. As an example of the different cases studied by this platform, this figure shows the percentage of retrofitting potential obtained by a single family at the upper part and for an isolated 4-story block with 400 square meters floor area at the lower part. Both cases have been evaluated for the different Spanish regulations and in the 3 climatic areas. As expected, the highest potential has been reached in all cases by the oldest normative before 1979 and being more remarkable for a single-family house. Starting from the first output, based on the climate, type of building and year of construction, more specific building models can be defined by this platform. The platform image shows the three upgraded measures that can be selected. The obtained outputs are the heating, cooling, and total retrofitting potentials achieved. The image left down shows an example for a single-family house of these evaluations for specific building configurations. Finally, let me conclude very briefly by saying that the developed platform will assist the public administrators and end users dealing with the problem in making the most appropriate decisions. The platform shows the theoretical high retrofitting potentials for the oldest regulations, being higher in houses than in blocks and more remarkable in single or isolated building configurations. Another important conclusion is that warmer climates led to higher savings. Well, I thank you for your attention, and if you have any questions or comments, don't hesitate to contact me by mail.